This is the second of 2 videos supporting Lesson 7.1.1. I will be reviewing the concept of the change of base formula and explaining the reason for that. If we were asked to solve an equation such as the one in front of us, 2 to the x equals 3, I have an idea of what that value would be. I could guesstimate or estimate its value if I actually just took a moment to estimate the exponent that I would have to raise it to get out 3. Well, I know that 2 to the first power, that equals 2. I also know that 2 to the second power equals 4. And again, I'm curious about 2 to what power is going to get me out a 3. So I know my value of my exponent, right? Because again, these are what these equal. My value of my exponent is going to be somewhere in between 1 and 2. So it is greater than 1 but less than 2. And I have that concept because, again, I know what 2 to the first power is. And so my exponent is somewhere in between. We might guess that because of the fact that it is equally far away from both, right? 3 is right in the middle of 2 and 3, that maybe I would have a guess that the exponent's value would be approximately 1.5. But with using logarithms, we can actually find out the exact value. The issue becomes that if we are going to use log as an operation which undoes exponents, again, a log undoes an exponent. It's the inverse function. I am very limited by most calculators, and if I take a look at my calculator here, we have only 2 different log buttons. We've got log base 10, and we also have the natural log, which is log base e. Again, as a reminder, e is a number. It's irrational. It's about 2.71. So these are my only 2 options. We actually cannot just rewrite this and evaluate it. We could rewrite it, but because we don't have a log base 2 in most calculators, we wouldn't be able to evaluate it without using either the common log or the natural log. So how do we change the base to a log that we can use a calculator to evaluate? So the first step, we'll take the log of both sides. So take the log of both sides. A log is an operation. It's also a function, just like square rooting. If we had x squared equals 4, we could take the square root of both sides. Likewise, we could take the log of both sides. So if I take the log of both sides, that just becomes log of 2 to the x equaling log of 3. So all I've done is, again, take the log of both sides. The second step is I will use the power property. So again, the power property of logs to rewrite it, and it being the equation. So again, the power property of logs is that when you have a power in a log, you can knock that power down to the front and rewrite it. So again, the power property from the earlier one is that this can come into the front and I could rewrite it. And so if I do that, rewriting this as x times the log of 2 equaling, again, the log of 3. Remember that, again, when I took the log of both sides, I was taking log base 10. When I don't write the subscript, that implies log base 10, which is a calculator button that we do have at our disposal. The last step is now to solve for x. So the third step is solve for x. And I do that by dividing both sides by log of 2. Again, this is a whole entire factor, and so we need to divide both sides by log of 2. So my final equation is log of 3 divided by log of 2. And that is, again, my final answer in terms of having changed the base. Log of 3 divided by the log of 2. In my calculator, now I can really evaluate that. So using a calculator, I will show what the solution is. So again, I'll turn on my calculator and have the log, and you'll need to close the parentheses. Log of 3, close the parentheses, divided by the log of 2. And again, I'm going to close the parentheses and hit enter. And we see that the value is 1.585. So I'm going to go ahead and record that down, that my x value is approximately 1.585. Now again, I could have done this with the natural log, and I could have even done this by rewriting the original equation with log base of 2, but most calculators don't have that value. So because the natural log is just a different base, you could do this with that as well. If I took the ln of 3 divided by the ln of 2, I get the exact same solution, the 1.58496. This is what is known as the change of base formula, where you take the log of both sides, you use the power property, and then in essence you're now solving for the exponents. Logs are incredibly powerful because, again, they knock down exponents.